All right, so at this point we've seen how to use threads and we've also seen how to use executors. So the last thing that we're going to take a look at, the last sort of construct that Java provides us with for working with asynchronous code, at least in Java SE11, is something called CompletableFutures. Now, I mentioned earlier that this is kind of a clunky name, but it's actually quite a nice thing to work with. All right, so let's just create a new class, and I believe I actually spelled this wrong a little bit earlier. It should be completable with the word table in it. That's a good way to remember it. So I'm going to say CompletableFuture examples, and we're going to create this, and of course we'll add a main method to it by saying public static void main string array args. And here's what a CompletableFuture looks like. It's actually it's even easier than what we saw previously. Basically, with a CompletableFuture, you don't need to even create an instance of anything. You just need to say CompletableFuture, okay? And that's automatically going to be imported for me there in my IDE. And we're just going to say .runAsync, and this is just going to take whatever lambda we want to run asynchronously and just magically make it happen behind the scenes, okay? So inside here, we'll say something like system.out.println. We'll say something like hello from a completable future. All right. And then underneath this, we're going to say system.out.println, and we'll say something like hello from the main thread. All right. Cool, so once again, just like with the other examples that we saw, if we run this thing now, sure enough, we see that hello from the main thread actually gets printed out first before we see hello from a completable future. And that's basically how we run things in a completable future. At least that's the simplest case, right? Now, the cool thing about completable futures is, right, when we have, again, the start and end of our program here, and we break off another timeline here that allows us to execute things in parallel, there are many cases where we want to actually rejoin this other timeline to the main thread and provide some sort of value, right? So just to give you an example here, we might have the main thread, which is doing something like maybe it's getting input from the user, something like that. So I'll just write main right here. But while that's happening, we might want to load the user's profile picture, right? Let's just use that as an example here. So we'll say something like load profile picture. And in this case, what we might want to do is when we're done loading that picture, we might want to make that picture available to the main thread so that it can do something like display it in the user interface, right? A little smiling face like that. And that's a very, very common use case when working with asynchronous code, is that these other threads that we create have to, they have a job to do, right? They have a mission to report back on when, when they're done, and they do that by making values, instances, lots of different pieces of data available to the main thread or whatever thread they were sort of split off from. So the good news here is that while this is kind of a tricky thing to do with threads when you're just working with threads, directly, CompletableFutures actually make this remarkably easy. And if you've ever worked with JavaScript and worked with something called promises, this is sort of like Java's version of that. Basically, in JavaScript, what promises allow you to do is they allow you to have some sort of async operation, right? I'll just call that some op, and they allow you to say .then and specify what you want to happen there as a callback function, right? A lambda, essentially. So that's almost exactly what these CompletableFutures allow you to do in Java, but in order to make this happen, we need to use something besides this runAsync method. What we're going to do instead, and here I'm just going to comment this out so that you can have that around for reference, what we're going to do instead is we're going to create something called a supply, and here's what this is going to look like. We're going to say CompletableFuture, and we get to specify a type here. This is a generic class, and the type is going to refer to the specific kind of data that this CompletableFuture is going to return to the main thread, right? So if we want this to maybe load a string from an API or something like that, we would say CompletableFuture string, right? If we wanted it to return an integer, we would say CompletableFuture integer. If we had some other data type like user, we could say CompletableFuture user. For now, though, we'll just make it simple and say string. And what we'll do is we'll say something like, get message, all right? We're going to name this after the task that it's supposed to perform. And here's what we're going to do now. We're going to say equals CompletableFuture dot supplyAsync, right? We use supplyAsync when we want the value that this task returns to be available on the main thread when it's done. Okay? So we're going to say CompletableFuture dot supplyAsync, and inside here, we can have our own Lambda expression, right? So here's what I'm going to do here. I'm going to say system.out.println, and we'll say something like inside a CompletableFuture, right? Something like that. And then whatever we return from here, right? So if we say return and return the string something like important message about the future, right? Something like that. just as a silly example. Oops, I hit the wrong hotkey there. Let's try that again. Then what we can actually do is when we want something to happen after the logic that we put inside this CompletableFuture and use the results that it's providing, we can say get message dot, and then we're going to use the method thenAccept, okay? So the way that this thenAccept method works is we can pass a lambda to this, and that lambda is going to take as an argument whatever the result was of the CompletableFuture, right? So if this CompletableFuture returned a string, then the argument of this lambda is going to be the string that it returned, right? And this is going to get called exactly when this thing ends. So here's what that's going to look like. We're going to say thenAccept, and what we're going to do is we're just going to say, this will be our string here, so we'll say something like message, and then inside here, what we're going to have it do is we're just going to say system.out.println, and we'll say something like just received this message, and then we're going to actually print out the message that we received. So we'll say system.out.println, and we'll say message inside of here. Okay? So that's all we need to do there. If we run this now, what we're going to see is that it says inside a CompletableFuture, right? That's from this thing right here. And then it says just received this message, important message about the future. That's from right here. And then it says hello from the main thread. Now, there's not really any particular reason that this hello from the main thread thing happened last when we ran it this time, right? That's not really something you can rely on too much. But the thing that's a little bit more important to realize about this is that this thenAccept thing, right, and these CompletableFutures allow us, or let me put it this way, they give us an easy way to take different asynchronous, things that are going on in our program and make sure that they at least happen in the right order, right? So we don't really care, for example, whether this hello from the main thread thing prints out first or whether this inside a CompletableFuture thing prints out, but we definitely care about this CompletableFuture ending before we print out the message that we've received from it, right? So that's the basic idea of a CompletableFuture, is that it just gives us an easy syntax to get the results from an asynchronous operation.